Hi, welcome to my NFT appraisal app walkthrough. In this guide, I'm going to show you how to build a simple app that takes a wallet's address or ENS name and returns the value of that wallet's NFT portfolio using floor prices. Even if you don't know how to code at all, you'll be able to follow my lead and build a website that's just like this one. You'll have a basic understanding of how it works by the time we're done. If you do have basic coding experience, when we're done with this guide, you'll know enough to edit the project and create a variety of basic NFT Analytics apps. I'll show you how to pull data from Alchemy's NFT API. We will write the code for processing this data in Python and test it out on Google Colab. Then we will create a front end for our app, the side of the website that people actually see in Streamlit, and deploy that website live on the internet using Replit. So yeah, let's get started. As I mentioned before, we're going to use Alchemy to get all the data on what NFTs a wallet owns, the floor price of those NFTs, their names, profile images, etc. Alchemy is a service that provides a lot of different APIs for getting blockchain data and for executing transactions, but there are lots of other products in the offering as well. To get started, we need to make an Alchemy account, but hold on. Actually, don't go straight to the Alchemy site. Please use the referral link I've put in the video description. That referral link won't make me any money. It will just help me track how many people actually followed this tutorial. Because, video views are cool, but I'm much more interested in how many people actually use these videos to build something. Okay, so once you visited the site using my referral link, you can sign up for the service, same sign up flow as you would use for any other service. So once you've signed up and given your email and all that, there's a little form to fill out. Nothing special here. You can pick the free plan to start, skip that, and maybe you'll just say that you heard about this through the Ko-fi tutorial or something along those lines. Just another thing to help me figure out how many people actually did this. And then we can get started with Alchemy. You're going to get shown to this dashboard, and your first app has already been set up for you right here. All you have to do to get your API key is click on this view key button, and you'll be able to copy and paste it from here. This is important. We're going to be using this API key to get all of the data that we want from the Alchemy service, so make sure you grab that before we head on to the next part. Now that we have our API key, we can get started on writing code. We'll be using Google Colab, which is a great tool for writing and running Python code in your browser. You'll find the link for this particular Colab page in the video description. So when you open up that page using the link you find in the description, you can make a local copy of it by clicking that button right here. And, local copy is great. You'll be able to edit how you like and save your work for later. So now we're in our copy of the page. Really what we want our program to do, our NFT portfolio appraisal program, is solve two problems. Get a list of all the NFTs owned by a specific wallet when given the wallet's address or its ENS name, and then get the metadata for those NFTs. Metadata being what's the name of it, what's its floor price, the picture, all of these different things. So here we're going to get started on the first problem, getting all the NFTs owned by a certain address. We will start off by importing a bunch of packages that will help us solve a bunch of different problems. You can run code in Colab either by pressing this run button right here or by holding down Alt and Enter. So, right now the Colab space is getting started up. That ran fine. Installed those packages. Our next step is that we are going to define the address that we want to look into. I'm starting us off looking at the address of dingaling.eth, who many of you might know as one of the largest holders of Bored Apes and Azukis, very active NFT whale. I'm also going to save our API key right there in another variable that we got in the last part of this guide. run that right there. Now we're going to actually call the Alchemy NFT API to get information about what NFTs does dingaling.eth own. And we also want to filter out spam, filter out airdrops. That's like, NFTs that other people minted to his address, because there's probably lots of those and we're only interested in legitimate NFTs. Now, right here, I've written out for you the code for doing that request from Alchemy's NFT API, but I'll show you how to basically get to this result if you didn't have this page. So let's go to your Alchemy dashboard and check out the docs. I mean, the vast majority of programming work is really just reading other people's documentation. I'll just search NFT API. That's good. We'll open up the documentation for that. The Alchemy NFT API has a bunch of different, services that you can check out for, like, if you want ownership information or metadata or what's happening with sales or rarity data. But we want ownership data. We want what NFTs does a specific address own. And for that, there's a particular endpoint called get NFTs that, as we see here, has what we want: get all the NFTs owned by a given address. Now, if we scroll through, we can actually see all of the different parameters that we need to give this API. The API key, we need to tell them like which address we're interested in. If we want to filter out spam and filter out airdrops, we need to specify that. And as I'm changing these things, these parameters, in this example, we can see that there's a nice little window on the side that will show us in Python how the URL has to look for making that request. So, you can just copy and paste that, but I've already done that work. It also provides it in a bunch of other languages, but we're using Python today. You can even use that button to try it out and see what kind of response you'll get, but we'll do that in our own time. And this is great. Check out the docs in your when you've got a chance. There's a bunch of other endpoints that give all sorts of other information, like who owns this particular NFT, or how many holders does this particular collection have. All sorts of useful stuff there. But let's get back to our page. So we're going to make that request for this data. And if we don't get back a successful status code, successful being 200, that's just the standard, then we'll assume that means that there were no NFTs found for that address. And then we are going to actually check out the response that we got, pulling the JSON from the response, JSON just being a standard data format. So we can see that we got a lot of information here, structured data basically telling us that, okay, dingaling.eth, that wallet owns an NFT that has this contract address, and the NFT has that token ID, and if it's ERC1155 type NFT, how many NFTs of that ID it owns. With 1155 standard, you can have many NFTs with the same ID. With ERC721 standard, there's only one NFT for every ID number. So you've got all of that information here about all of these NFTs that this wallet owns. And there's another interesting thing here, which is the page key. This particular endpoint that we're using, the get NFTs endpoint, it can only send you 100 NFTs at a time. And obviously, like a wallet like this wallet has way more than 100 NFTs. So if there's more pages of NFTs to flip through, they'll let you know by putting a key for the next page at the end of the response, which is going to be useful in this next step, where basically we're going to have a conditional statement saying that, hey, if there is a page key in the response, we want to run this code to execute a loop and call the endpoint multiple times to get more pages. It's basically what's happening here, that in the case where there's a page key, we're going to go through this loop, and if there's no page key, meaning that that wallet had left less than 100 NFTs, we'll just run this other piece of code and move on. Interesting points here. I changed the data type of what we got, of our response. I changed it from JSON to data frame. In Python, data frames are, a basic table format. Think of it like an Excel spreadsheet. There's rows and columns, and there's pre-built functions. And also, apart from pre-built functions, you can write some of your own, but we'll deal with that later. And I'm just grabbing, as we can see in our JSON, there was some data in this owned NFTs bracket, which is basically what we wanted. So I'm taking that owned NFTs data, converting it into a data frame. Every time we run that loop and call the endpoint again for more NFTs, we convert that into a data frame as well, and we join the data frames together using Python's append function until there are no more pages left. So that's what this script here will do. That might just take a minute to run because, this particular wallet has tons and tons of NFTs from different collections. So I'll anticipate that it will take a minute. Great. Now we can run this line here to check out the data that we got from Alchemy. We are saving this data in the variable holdings. And if I just ask for the head, it will just give me the first few rules of that table. And as we can see, we've got a table now that has a column that has contract data, a column that has ID data, and a column that has the balance, converting the format that we've had here into a easier to read table format. Now, this table can use a little bit of cleaning up. As you can see, the contents are a bit messy. So we'll go through a few steps here. We're going to change the balance data from a string type, which it is currently, into a number. We're going to make a new column called address, where we are actually going to take the raw contract address out of this, data structure that's currently in there. And apart from that, we're just going to cut down the table a bit. So we only really need the address column and the balance column. Everything else we can get rid of it. Final step we're going to do is that we are going to sum up the balance of NFTs for each contract address. So if we have, say, the contract address of Bored Apes, we want to know how many Bored Apes does this person own. So we're going to sum up the balance by the contract address. That's what all these lines here do. We'll run that. And now we'll check out our new table. As you can see here, it's a lot cleaner. This is a very simple view of, for the address, for the wallet we were looking out for, it owns NFTs with these different addresses, and this is how many it owns. There's a few good simple steps there. You can follow along, run this, and then we will move on to the next part, which will be getting the details of all of these contract addresses that we now know the wallet owns. Okay, so in this step, we're going to get the metadata. So that's the name, image, other such information about the NFT, and the price data for all of these NFTs that we now know is in our targets wallet. So we have the contract address, we know how many they are, but we don't have all of this other interesting information that we want to show in our app. So for this problem, we're going to use another one of the endpoints from Alchemy's NFT API. Before we used get NFTs to get the list of NFTs, and now we're going to use an endpoint called get NFT metadata batch, which allows us to fetch a bunch of this metadata at a time. As you can see, it gives us exactly what we want. It will get us the metadata of NFTs when given a list of contract addresses, which is what we have. And, same as before, in the documentation, we can see the parameters we have to pass to this request. We can see exactly how we need to write this request in Python. Got a great example right there, and we can even try it out. So we're going to take this example code that we've been given in the documentation, and we're going to apply it here. If the number of NFTs in the target wallet is less than 100, so we check the length of this table we made before. If the length is less than 100, we can do all of this in one go. We'll convert the address column of the table into a list, and then we will pass that list into the request, and once we get the metadata batch, we convert that into a data frame table. So that's really simple. But as you know, in some cases, a wallet might have hundreds and hundreds of different types of collections, in which case we need to approach things a little differently. So, in our conditional statement, we have one block of code for if there's less than 100 contracts and another block of code for if there's more than 100 contracts. And in this more than 100 case, we use this line here to tell us, okay, this is the length of the table. Divide that by 100 and tell us how many groups of 100 are in the table. And then split that table into as many parts as there is. Finally, we have a loop where we go through all of those parts and get the metadata for those batches one by one, put those in a list, and merge that list into one final metadata table. So there's a lot happening there, but you can read through all the comments and try this out yourself. We're going to run this code block and see what we get back. Now checking out the head of our new metadata table, we have a table where on each line there's a contract address that we know our target wallet owns, and a bunch of metadata. Its name, symbol, all sorts of stuff. Now, we want to do some transformations on this data because it's not in the format that we want. All the contract metadata is smushed into one column. So we're going to write a bunch of custom functions that we can apply to this table. So, in the past, we've used some pre-made functions that already exist, like this group by function. Don't need to write the logic for that, it already exists. But you can also apply functions to a data frame table that you make yourself. So here I've defined a floor price function that will check, it will try to go into the contract metadata, line item, and underneath the OpenSea section, get the floor price. And if it doesn't find anything there, it will just return a 0. There's also a getName function that will, again, go into the contract metadata line item and try and get out the name. And if it can't find the name, it will just return an X. And finally, another function that will try and find an image. And if it doesn't find the image, it will just return an X. Because there are some cases where the Alchemy API might not have that information, but we don't want our code to not work in those cases. We just want to add in some reasonable replacement. So we're going to create those functions, and then we are going to use apply to apply those functions to our tables. So these functions will be applied to every single row in the table to create a column called name, a column called image, and a column called floor price, getting out the information that we want. So now at this point, we've got two really great tables. I'm gonna just take a look at the metadata table now. We've got a table that gives us all of this information, and then we have another table that gives us the quantity of NFTs that the wallet owns. So we want to merge these two together. So we're going to use a merge statement. we're going to merge them based on the one column that they have in common, which is the address column, to make an entirely new table called portfolio. We can take a look at portfolio here. As we can see, it has, for our target wallet, all the NFTs, their contract address, how many is owned, the name, the image, and the floor price. And so now we're reaching the stage where we have pretty much all the information that we want to show on our final app project. We're just going to do a bit of filtering. We're going to filter out collections where the floor price is 0, where there's no floor price, because they're not really worth anything. And the whole point of this project is to figure out what is the value of a wallet's NFT holding. So if something is valueless, we can just exclude that. And then we're going to cut the table down to only include the columns that we need. And finally, we will create a new column called value that will multiply the balance by the floor price and get us the value of each collection that the wallet owns. So if this person owns 10 Bored Apes and Bored Apes are worth 10 ETH, it will multiply those two numbers and say that, okay, the Bored Ape balance of this wallet is worth 100 ETH. So we'll do that filtering there, take a final look at our new table that has all of the information that we need for our app. And we are also going to calculate the sum of our value column to get the final value of what is the ETH value of all of the NFTs in this wallet, and get a nice little number there. So now in our Google Colab page, we've run through a bunch of code that serves two purposes: getting a list of NFTs that the wallet owns and how many of that NFT the wallet owns, and then getting information about that NFT from Alchemy using Python, and always referring to the docs anytime we get stuck on how to make a certain request. And now we can move on to the next part, where we are actually going to make the front end for our app, the bit that people are going to see, and how we deploy that as a live website on the internet. In this final step, we're going to convert our Python script into a live website. We're going to be using Streamlit, which is a framework that makes it dead easy to turn a Python data analysis script into a web app. And we're going to write this new Streamlit app on Replit. Much like Google Colab, Replit lets you run and write code in your browser, but has a lot more functionality than Colab that will be useful for what we need to do next. First thing I'm going to need you to do is sign up for Replit. It's the same process as anywhere else. And once you're done signing up, here's what your homepage will look like. Once you're in here, you can click on the link to the NFT appraisal Replit projects that I've put in the video description. I've already got that open in another tab, and that will bring you to this page. We're going to go ahead and fork this project to make our own copy that we can edit and save and do all of that good stuff. So yep, I'm just going to fork that, and it will bring us to our new workspace where we're going to get started. Here we can take a look at how my Streamlit project is structured. There's only one file in here that's actually important. It's the main.py Python file, and the vast majority of the code in this Python file is just copy-pasted from our previous Colab project. First, we're installing some packages. These are the same ones as we used before, but now with the important addition of the Streamlit package. Then we've got the functions that we wrote in the previous part for cleaning up our metadata table. So you can see that these are the exact same ones. Only change is that if there's no image, the getImage function returns a default image that I've added to the project. And if there's no name, the getName function returns name not found. After that, we've got this really big function here called process data that contains most of the logic we wrote before. It takes in the response from the getNFTs API and the address of our target wallet. It fetches more pages of NFT data if there are more pages to fetch. And then it gets the metadata for these NFTs, same way as we did before. And finally, it merges together the NFT list table and the metadata table to create the portfolio table, which has all the information we want. The name of the NFT, quantity, floor price, image, value, etc. So now we're getting into the Streamlit specific part of the file. I think it would be much easier to understand this code if we run our website and compare things side by side. So if you go into the shell tab right here, you can run this command, streamlit run main.py, main.py being the name of our Python file, and run that to bring our website to life. All right, so now we can see our project in action. That took a long time, maybe like 5 minutes or so to load. But we can now scroll through, take a look, and see how all these items were created. One note, the first time that you run this streamlit run main.py command, you'll probably be asked to enter an email here. You don't actually need to enter your email. You can just press enter and it will keep on with loading up the page. So now let's take a look. First thing, we use the streamlit set page config function to set the text that you'd normally see in the tab up here if you were to open this site in your regular browser. Then we display our title using another streamlit function called st.title, so we can see that over there, and we can change it as we'd like, and it'll change on the real app. Oh. Yeah. You can always refer to the Streamlit docs if you want to add some new element, but you don't know the function name for it. So you can go into the documentation and go to API reference. You can see here that they've got lots of examples of how to create all sorts of text and graphs and different types of inputs, including the title function that we just used right there. So after that, we include a little label that links to our Twitter account that we can show off. And here we create this text label that you see, as well as the text input that you see. So the box where users are actually going to input the ENS name or the address of our target wallet. I've got a default wallet in there, so when the app loads up, this is the wallet that it automatically starts searching for. This wallet is saved in a variable called owner, and that variable is added to our Alchemy API URL to get the data from Alchemy's Get NFT API. If we get no response, we'll display a title that says no valuable NFTs were found. And if we do get a response, we take that data and we give it to the process data function in order to get back our clean portfolio table. After that, by summing and rounding up the value column of our portfolio table, we get the total ETH value of the wallet's NFTs, and we display that in this element here. Last step, we're going to make all of these collection summaries that you see. Let me expand that so you can see what they're really meant to look like. That's the full page. We'll make all of those, and the way we'll do that is by looping through the portfolio table, and for every row in the portfolio table, it will make a container with 2 columns, put the image in the first column, and put the name, price, and balance of NFTs in the other column. So that's a rundown of how our web app works. It's live on the internet right now, so you can open it up in your browser and you can share the link. It will be a bit slow. You'll probably have to reload the page a few times, and you'll probably get a warning like this one because, you know, it doesn't have, an HTTPS certificate, but you can kind of ignore the warning and go on to take a look at your website. And as you can see here, it works good as new. We can enter some other address to check it out, like we can check out cry.eth, and it will run that and give us the breakdown of that wallet's portfolio. And yeah, you can experiment with any wallet that you'd like. Now, this website won't actually remain on after you close your Replit workspace, because website hosting is a paid service on Replit. So, you know, there's this always option on here, and, you know, there's some options for that. I think it comes out to being about, you know, $6 a month if you want to keep a website live all the time. But you don't need to do that. If you know how to use GitHub, you can go to Streamlit and you can host it for free using Streamlit's cloud option. And there's some guidance about that here. All right, so now you've built your first NFT data app. Congratulations. We've walked through the basics of using Alchemy's NFT API, Colab, Streamlit, and Replit as a Python programmer. This is just the start of your journey. For more educational materials on how to use these tools and how to write code in Python, you can check out the links that I've put in the description. Thanks for taking the time to run through this lesson. Let me know on Twitter what you thought, whether it needed more explanation, less explanation, what you'd like to learn to make next in future videos, and any other feedback. I'd really appreciate that. You can try editing the code from this guide to make your own stuff. You could, for example, try building an app that summarizes data on an NFT collection when given that collection's contract address. Really, the possibilities are endless if you just kind of mix and match the APIs that are available and all of the tools that we've just tried out. And yeah, I can't wait to see all the cool stuff you guys make. I will see you in the next video.